Good morning, guys. Hope everyone is doing well. Yesterday, you guys took your quiz on 5.1, and what we'll be moving into today is section 5.2 on proving trig identities. So now what's really nice is that section 5.1 and 5.2 are almost identical, except for in 5.2, it's actually a little bit simpler because they give you what you should have in the end. So the whole time you're simplifying trig identities in 5.1, you don't necessarily always know what you want to simplify to. Is it sine? Is it cosine? Is it sine squared? You don't know. This will actually tell me what I want to simplify to. So it makes it a little bit easier. On the first page of this notes, I have general strategies for proving identities. So the difference with proving identities you'll see is that there are two sides to it. And there's always going to be a side you're going to start with. You're not going to touch the other side. That's only what you want to simplify to. It's just they're basically giving you the question and the answer, and you have to do the work to get to the answer. So my first general rule is always simplify the more complicated side of the identity. So I always say it's easier to break something down than build something up. And then my other tip is only work on one side of the equation. You're going to see today, I'm going to combine all the strategies we did with simplifying, expressing in terms of sine and cosine, looking for Pythagorean identities, factoring, multiplying by the conjugate, common denominator, all things we're still going to use. Just now we are going to be proving the identities. So let's look at an example. So now if you guys notice with this, there's now an equal sign, and there's two sides of the equation. So what we're going to do is, in the past, you would have only been given maybe the left side, and you wouldn't know what you would simplify it to. Now they're actually giving you an answer. So which side do we start on? It's not always going to be a left or the right. I can't always say, always start on the left, but I can say always start with the bigger side. And I don't know about you, but I think it's very clear to see that tangent squared plus sine squared plus cosine squared is bigger. So how we go through this identity? Well, as soon as I see sine squared plus cosine squared, right, I'm going to simplify that piece to 1. So I'll have tangent squared plus 1. Now, what is tangent squared plus 1 equal to? It's an identity. What is an identity? Secant squared theta. How do we know we're done? Because we got to the other side. We got our left side to equal secant squared. You are only touching one side. So you are only touching one side. The other side is just telling you what answer you want to reach. Okay? Our next example says cosine of theta times secant minus cosine equals sine squared. It's easier to break it down than build it up. Start with the bigger side. So I'm going to circle the side that I'm starting with. And I want to know at the end, when I simplify this, I know I'm done when I get to sine squared. So what am I going to do? Well, it's not very clear. What I see is, in parentheses, I see secant minus cosine, and outside I have a cosine. So I'm actually just going to start this by just doing some basic algebra distribution. So I'm starting with cosine times secant minus cosine. And guess what? I'm just going to distribute in the cosine. So what I'll get is cosine of theta times secant of theta minus cosine times cosine is cosine squared theta. Now, what I'm going to do is, I don't like the fact that I have a cosine times a secant. I don't like that I have a secant. So I'm going to rewrite the secant in terms of cosine. So secant is 1 over cosine. And then I have the minus cosine squared. What happens when you have cosine on top and bottom? Well, at this point, you know they're going to cancel. But do not lose your 1. You need that 1. So I'll have 1 minus cosine squared. And guess what? What is that equal to? Just sine squared. Am I done? Did I end up equaling my right side? Yes, I did. So I'm done. Do not touch the right side in this case. Leave it alone. So we're seeing a lot of the same strategies, just now we know the other side, so it's a lot easier to approach it and know when we're done. Okay, the next one I have as like a you try, but of course I'm just going to do it together. Of course I'm going to start with the bigger side, so tangent times cotangent over cosine, and I'm going to put everything in terms of sine and cosine. Why? Because I want to end up with secant at the end. I want to end up with secant, so I know if I can end up getting 1 over cosine, I'll have secant. So I'm going to make tangent sine over cosine. I'm going to make cotangent cosine over sine all over my denominator of cosine. Now, I don't know if you guys see it, but if you look at the top, the cosines cancel, the sines cancel, and I'm just left with a placeholder of a 1 over cosine of x, which, just like I wanted, is secant x. Now, you know the other side of the equation. Use it to help you. I will be checking your work, though, because you can't just say, oh yeah, I have this work, and then jump to the answer because you know what it is. You have to show me it worked out in between. Another thing you could have done for this problem from the beginning is recognize that tangent times cotangent. So you could have made cotangent 1 over tan. Tan times 1 over tan just becomes 1 over cosine. So you can do that as well if you see it that way. That's fine. You'll still get the same answer. Okay? So if there are any questions, stop and ask. There's really nothing new here. It's actually simpler than before. So make sure if you have questions, you're asking me. Okay, let's go to the next one. So on the next one, it's easier to break it down than build it up. If there's one side that has a fraction, you start with that side. So I see sine squared on top over 1 minus cosine. Now, I've been telling you guys over and over, and we've been seeing this. Whenever you have a 1 minus cosine or a 1 minus sine, if it's not squared, if it's 1 minus cosine and it's not squared, you cannot make it a Pythagorean identity. Some of you are making 1 minus cosine sine. That is not true. 1 minus cosine squared is sine squared, but 1 minus cosine is not equal to sine. This is not a thing, and it's very, very important that it is not equal. Okay? Just like 1 minus sine is not cosine. 1 minus cosine squared is sine squared. 1 minus sine squared is cosine squared. Okay? So what am I going to do here? The same thing I've been telling you to do. Multiply by the conjugate. The denominator is 1 minus cosine, so I'm going to multiply top and bottom by 1 plus cosine. So I'll get sine squared times 1 plus cosine over, and I'm going to FOIL at the bottom. Now, we've FOILed something like this out many, many times. The innards will end up canceling, and it'll just be left with 1 minus cosine squared. Now, what's going to happen here is I have sine squared on top times 1 plus cosine over my denominator of 1 minus cosine squared. 1 minus cosine squared is the identity sine squared. And then, guys, what ends up happening with the sine squareds? They cancel. I'm just left with 1 plus cosine. How do I know I'm done? Well, what I wanted to get and what I got were the same thing. So, conjugate is super big here, and it's not going away. You saw it on your quiz. You're going to continue to see it. Okay? So far we've seen turn it in terms of sine and cosine. We've seen Pythagorean identities. We've seen distribution, basic algebra here. And, of course, our conjugate. Okay. Example 5. So, sine of theta over 1 plus cosine theta. Now, the reason why I put u try next to this is because this one is a conjugate again. So I'm actually not going to work this out on here, but if you check the worked out notes that I've attached on Google Classroom, you'll see this worked out. And again, it's the conjugate just like the one before this, and then I split it up and I get my answer. But I just didn't want to waste time on the video since the one before this was a conjugate again. Refer to worked out notes. Okay? Okay. Let's get to our last two. So in our next one, this is always a hard problem on where do we start. So what I always suggest is it's easier to break it down than build it up. I think the longer part here would be anything with a plus sign. Multiplication is always fairly simplified, but I'm going to start on the left side. because it's easier to turn addition and then maybe have a common denominator. So I'm going to start on the left side, and if you can, always start with addition over multiplication. So I'm going to say, well, I'm starting with tangent, cotangent. I need to end up with secant and cosecant. Secant is 1 over cosine, and cosecant is 1 over sine. So I need to end up with something in terms of sine and cosine. So what I'm going to do is kind of ignore what I just wrote for a second. I'm going to start on the left side, and I'm going to turn tangent and cotangent in terms of sine and cosine, like I've been doing. So, tangent is sine over cosine, and cotangent is cosine over sine. Now the big question is, did that help me? Well, I now have a sine and a cosine, but I have different denominators. When I have different denominators, what do I have to do? I need to create, I'm going to get rid of this piece, create a common denominator. So what is my common denominator going to be? One of my fractions has a sine, one has a cosine. So it's going to be sine of theta times cosine of theta. So I'll multiply the right equation by cosine over cosine to get my denominator I need, and the left equation by sine over sine. Okay, now I'm going to clean it up. So you multiply the top, and then you'll just have your common denominators on the bottom. So sine times sine, sine squared, over sine cosine. Cosine times cosine is cosine squared, over my common denominator. Now, just like with fractions, we're going to add the tops and put it over the common denominator. So I'll get sine squared plus cosine squared, which should look nice to you, over my common denominator. Sine squared plus cosine squared is my identity. It just equals 1. And guess what? 1 over sine is cosecant. 1 over cosine is secant. Because it's multiplication, it doesn't matter if the secant comes before the cosecant. It's just, commutative. Okay? So far, we have seen every single one of these problems before. Some form of it. Okay? It's the same thing, but now we know what we need to get to, and we can check ourselves and say, yep, we did it right. We know we're good. But you cannot touch both sides. You can only work on one side, because then it's not an identity. You're not proving anything. So only work on one side. If you go working on two sides, I'm going to know you didn't watch the video, and I'm going to have to, you're going to have to redo some of your work to make sure that you're getting the right answer. Okay? Let's move on to our last example. Now, the last example is definitely a little bit challenging. It's the most challenging problem on here. It is a common denominator problem. Now, it's just long. That's the only reason why it's challenging. So if I look at this problem, 1 over 1 minus secant plus 1 over 1 plus secant. Now, there's only one way to do a problem like this, and it's common denominator. One of my fractions has a 1 minus secant, one has a 1 plus secant. So what I'm going to do is, the one that has a 1 plus secant, it needs a 1 minus secant. The one that has a 1 minus secant needs a 1 plus secant. Okay? And now I'm going to multiply the tops, really just multiplying each one of them by 1 and putting them over my common denominator. So I'll get 1 plus secant over my common denominator plus 1 minus secant over my same common denominator. Now, some common error that I'm seeing is many of you guys are then going and canceling your common denominator that you just created. Don't cancel it. You created it for a reason. Okay? Now you're going to just add the tops and put them over one denominator. So 1 plus 1 is 2. Okay? Secant minus secant goes away. So I get 2 over 1 plus secant on the bottom, 1 minus secant. So here's my thing. Now, because we are solving, I know what I want to get to. I want to get to -2 cotangent. I'm happy because I see I already have a 2 on top. So I'm going to rewrite my 2, but the bottom needs to get me some form of maybe tangent squared. So what I'm going to do is, the only thing that I can see to do is FOIL the bottom. If I FOIL the bottom, I'll get 1 minus secant plus secant minus secant squared. And what happens is the secants cancel. I get 2 over 1 minus secant squared. So this is the only part of this problem that gets pretty challenging. And I don't expect you to know this step. The problem that I gave you on your homework doesn't have this step. You just plug in the identity and you're good. So the normal identity is secant squared minus 1 equals tangent squared. So what I need to do is factor out a -1 in the bottom. I get secant squared minus 1 then, which is 2 over, and this is my identity, negative tangent squared. Now, I don't want tangent, I want cotangent, so I'm going to flip it up. So I get -2 cotangent squared theta. The one on your homework sheet, I believe, you go through the entire problem like I did, and when you get down in this step, you'll end up just getting a straight identity in the bottom, and then you can just flip it up. Okay, so you won't have to worry about factoring out a -1 like I did. And I wanted to give you ones on the homework like that. So this is really, if you look, this is 5.2. It's just solving. All of our techniques are still the same. So I want you guys to go through this, try your homework, okay, take some time on it. It might take you a little bit. The next day that I quote-unquote see your class, you're going to be working, so your next class, so work on your homework, right? And then next class, what you're going to do is work on a review for 5.1, 5.2, and then the class after that, then you're going to have a 5.1 to 5.2 test. It's not going to be as many points as a test normally is. I think it's like 30 or 32. There obviously are not going to be corrections on it because it's open notes. I want you to use everything you have, but please know that that will be your last grade for the marking period, okay? And your grade will be as it stands. So unless you hand in any missing homeworks or anything, your grade will be as it stands. There's no corrections on anything else. It's just hand in any missing assignments you have, and we'll go from there. I will know if you did not watch this video because you won't be aware of this information, even though I'm posting it on Classroom every day. So make sure you're going through Classroom and asking me questions if you have them. Okay? Good job today, and let me know if you need help on the homework.